Um, Today we'll be continuing on the Objective 7, and we'll be technically finish it, and hopefully we can have the exam review on Friday before the third exam um, on next Tuesday, which is November 18th. I just want to let you know um, we must take the post module knowledge check because that's one is very important part of the exam questions. Okay, so I will let you know the number of questions that we have and the topic that we should focus on. Okay, let me start with let me continue on objective 7. Uh no, the data day it should be it sh I'm sorry. The data day should be like it should be after the third exam. So it's basically on it's on 21st, I believe. So let me just double check the calendar quickly. You're gonna get two more data dates. Okay. So we're gonna get like two more data dates. Okay, so make sure to double check with the connection browser, locked out browser, something like that. Just making sure that we have all of this and the camera. Okay. So make sure it all work. And so the exam review. So we're gonna finish objective. It's gonna be on 14. So we're technically going to finish objective 7 plus the exam review. I would try to go over like all the topics that we should have before the exams. Making sure that we have this date. Um, so the date 3 should be right after. Oh, yeah, it's on 22nd. I'm so sorry. I don't think we have no, I'm sorry, 21st. It's gonna be on 21st. It's gonna be November 21st. Okay. All right, guys. So I will send out the instruction. I need to fix something with a certain notes. Okay. I'm gonna send out the data day 3 guy by Friday. Okay. So I want you guys to have like the whole week to know how to, like do all of these instructions on Jazz. It might be a little bit hard. So I hope that all of yous gonna do it. Okay, I think I forgot to record. Oh, I did. Anyway, so uh the data day guy will be posted. Okay. So make sure you're gonna check the email and by space and all of this. So that's very important. You have those and email. And so it's important. It's very important that people are gonna practice this because the third daddy day and the last daddy day are gonna be more strict in terms of the grading because you guys knew exactly what to do, what expected you to do. So just read the instructions, try to perform this. Don't wait until like November 21st to do it. It's gonna take so long. It's won't You won't have enough time to write the report. Okay. I will post it very soon, Nico. I'm so sorry about that. So for a little, so this is gonna be on Friday. Um, okay, I'm gonna post it. You guys, you will be people making up the data date too. We have like 24 hours to complete the data date and post and submit it on Brightspace. Okay. All right, so just want to make sure that the objective 7 is due on Sunday. I know it's kind of like inconvenient for you guys to complete them on Sunday, but like I said, there's no extension, obviously no extension for the Saturday 7 because I need you guys to have at least 2 days uh, to practice all the modules 5, 6, and 7 for the third exam. So I repeat myself again just in case that people don't don't get an email that I sent out in this morning. So the objective 7 is due on Sunday, so no extension. If you don't do the data day, it's impossible to get a good grade. Even if I know some of you maybe have like a really fantastic like run before the exam. Some of you might just absolve like all the material, but like I said, I don't want to see people like cram for the exam, like study like straight 8 hours before the test. That's gonna be a little too much. And make sure that exam 3 is cover uh three three module 5, 6, and 7. Okay. All right, so let me continue on what we have so far and um and very likely that we have to finish it. There's still a lot of topics, so I need to move forward. Oh, I think not this part. Let me just double check. Yeah, okay. So those two questions critically important. Um, so it's literally one of the things that you might have on the exam. It's, it doesn't look so good, but um, anyway, so that's what we have over here, and then we need to set up the hypothesis. It's based on a certain keywords. The keyword that we have is differ. Okay, the word differ. Differ. It's gonna be two-toe because we have to test on like either it's greater or less than, so you have to be on both sides. Okay, two-toe. Okay, so um. So when you write up the hypothesis, have to be something like uh this. So we write up hypothesis, so you have to start with a mu. Okay. On top of that, always hit equal sign. Okay, always hit equal. It's basically the no hypothesis is where we're trying to reject in order to accept the claim. So the no hypothesis is something that we have no information of. Um, there are a lot of statistic book that use um, the opposite side with the attack hypothesis, but the no hypothesis is a main factor in our test because we have to focus on something that we don't truly know. Okay, so there's something that we have no information of about the range of the population mean. So it's based on the analysis that being tested about so the mean was about 141s. So this is what we given. Okay. And on top of that, on the alternative hypothesis, you're going to put different because this one is 212. So it's have to be 141. Since the question gives population standard deviation, so population standard deviation is given. So which is this one equal to like 13.
Yeah. But you're not beyond.
So we have to use the z-test, right? Yeah, z-test. Okay, 100%. So we're gonna take the z-test, and then we need to find a critical values based on the calculator. Since I'm not gonna just write up the formula, but I can do that. Just hold on a second. You're gonna have the
I got a PayPal and the it's corresponding reservation. The reservation that we hold on. Hey, do you have like a weird time class? Is it early morning? No, 9 a.m. They give you the same recipe. Are you sure it's for that section? Yeah. Oh, they like almost never do that. Really? Yeah, they actually try not to do that. That's weird.
it looks very blurry for some reason. I don't understand why.
It's the lecture is.
Yeah, it looks better. And then you're gonna compute the z-score based on the
Yes, yeah, I mean, it's pretty.
x bar minus the mean.
Yeah, they're just gonna be thinking a lot. One time when I did in the summer, well, because the summer pacing was different, so I was like slightly behind and I just used the recitation time. Yeah, I mean. You can do more time. But we have less class meetings in the summer, so that was tougher. Oh, really?
And divided by standard deviation.
Instead of an hour and 15 minutes, it's 2 hours and 15 minutes. Oh, okay. But then the lectures are like coffee, you have to.
And times radical n.
And then because it's that long, I do give them a break.
Radical.
And then on the test days, the whole class is for the exam, so it's like an extra 25 minutes off, so it is actually like less time, if that makes sense. Yeah, no, for sure. Mm-hmm. So.
All right, so we just have to plug that in and then compute it. So we're gonna take divide first, and then x bar was 141. I'm sorry, x bar was x bar is 138 minus 141 divided by the standard deviation, which is 13 over radical n, which is radical 25. Okay.
What? Oh, like on Zoom. There's no different questions down from the ones I got wrong.
And then essentially it's gonna give us the answer equal to negative 1.153. Okay. 1.154, something like that.
What you got there. Chapter 101. Did you start chapter 10? What, right? Right now, no, not yet. We have, we're doing group 2 today and exam is on Friday. We'll yeah, my exam is also Friday, but I don't know, I guess it's deep. I don't know how it happened. I'm not trying. Forward. Huh? You're pretty.
All right, so And after that, we need to find the critical values. So the critical value for two-toe. So we're gonna start it with the z-score. Okay, so we look at the alpha. So the alpha was given like 1%, the significant level.
Professor, can you let Jasmina in the Zoom?
I'm sorry. Oh, yeah. Just give me a second. Yeah, yeah. Okay. So this one should be given, and then we call them alpha equal to 1%. So when we compute the z-score, since that's taking into account um the entire alpha. So it's based on two-tail. So when we trying to get for the z-score, so this is 1%.
What are you asking? What are you asking? Oh, it gave us divide. Divide? Or like simplify.
So this is 1%.
Or rational? Are you being asked the rational of the denominator?
And then when we write the z-score, it have to be like the z of you have to divide it by 2, so 1% is so that'd be 0.005. So we're gonna take 1% alpha over 2
Relatively no comes faster, right? Like that's squared.
is 0.01 over 2 is 0.005. So we have to both you have to take both you have to take both uh negative and positive part. So you might end up with 2.57 2.5758 a 2.576. So it have to be plus and minus, right? So we're gonna take that as negative 2.576. All right, guys. So the thing is that the this so so when we trying to take on this chapter, we have to make sure that the testing value will be coming from the alpha. So we don't really care about the positive part because the z-score that we have was negative. So this is like 2.576. Apparently that is the testing values.
So, how do you
So the z-score that we have was like negative 1.15. It's simply stay inside of the confident level. So we cannot reject the null hypothesis. Okay. So negative 1.15 stay in HO.
but you want to so yeah stay on this before like getting the
So we cannot reject null hypothesis. So we do not reject.
so you want to get from here to a point like you remember like how we did the rational
HO,
you want to multiply each of these terms
meaning that we cannot claim anything.
that
And
makes both
we
5 times the number
cannot
and within cube
claim
and
anything.
x times.
Okay.
So what is
Another way you can do it is just simply compare with if the z was 1.15, something like that. It doesn't matter. But I just want to let you know how we're gonna reject or accept no hypothesis was less than the ZC.
well, just you're adding
The critical value
why
is 0.005.
right because I squared then you actually really want
So we do not reject
so overall
HO.
here you can do this, but there will be more work to do in terms of simplification after. But this is not, this is.
It means that we have to reject the claim.
But doesn't change, but for 25, because 25 is already a square, you actually don't need to multiply by.
All right, as simple as we have so far.
Just need to multiply by 5 plus. That's just.
So no, we cannot say anything. That's pretty much it. Any question? Are we good?
Like X, right?
Okay, so yeah, this is just a question like that. You can try another one, but um so this is one tell. I just want to do it fast. It's greater than 588. So the mean was greater than 558. You can't just watch the video and watch you practice this question. And then on top of that, just put the mean equal to 5.8 588.
Nothing wrong along the route.
Okay, so I just want to post that real quick for this. It's this very important thing because the other chapter is basically the same concept, the same approach that we can solve it quickly. I don't think I have enough space. Just let me move up to the next one. And then since the population standard deviation was given, you have to use the z-score because the population standard deviation is given. That one. The keyword is very important to identify on the exam is greater than 558. So now, and then when we compute the test value, just simply go from like, um, we just simply go, we take, you have to divide first, take the sample mean was 593 minus the testing value is 588 over the standard deviation equal to 36 and then divided by radical n, which is radical, the sample is 100 student. So we can simply compute this. I don't think I have enough space for that.
You will be, I'll make sure that in the exam, if you're on.
And then that's gonna give us the answers 1.39, 1.389.
If there's anything to simplify first, but then because, so basically like what you did with this problem, like put everything, like the quotient rule, you put everything under the same radical. If there was something to simplify, then you could have simplified that, but then you would have had to split it again. So say that just that.
And then you just put down 1.389. And then the critical value, so this is one tell. And then you're gonna go for like the alpha is 5%, significant level. So that one is 5%.
In this case, you can
Okay.
factorize the denominator immediately, and then simplify.
So we don't divide it by 2 because this is one tell.
Simplify the 7/49.
Work greater than is actually the right tail test.
Then
And then we can compute the critical value, which is 0.05. So remember, if this is on the left tail, you're gonna change the side to the negative. So let's say 0.05, but let's say I test on the left side, so you're gonna change that to negative 1.645 instead of 1.645. Okay, you're gonna change to the negative 1.645.
yeah, they're the same.
So this is the right tail, so the answer for that is positive. 1.645. This is the right tail.
At your left, that when there's something to simplify,
Because the work is greater. Then the z-score is positive. It's positive. If the if that is the left tail test, the left tail, the key will be less than or fewer than, something like that. So the z will be, we change to the negatives. We change, we use, we change to the negative critical values, right? Okay, just making sure that we have this. Okay. All right. Any questions? Any concern? All right. So, and then we can compare them. So we can say if the z was okay. So this is just a little remarks. If the z was greater than was equal to 1.89, 389 was less than the z, c, uh, z 0.05. So what we can say would be we have to reject, we fail to reject no hypothesis, right? Do not reject because that's still stay in the confident level where we have no information is kind of different, right? Um, so we do not, we cannot accept the claim because the mean can be any point that move from one point to another. So we cannot accept the claim. All right, as simple as that. Any question? Okay, so if there's no question, let me move up to um move up to the next topic quickly. For the confidence level is we basically use the exact same techniques. Um, so let me just take one example. For the p-value approach, instead of using a critical value, now we're using a probability to compare. If the probability was stay inside of a confidence level, like HO, then we have no information. We cannot say anything about the claims. We don't have enough knowledge to claim. If it stay outside of a confidence level, so stay basically out of it. So meaning that we can accept the claim with a very low likelihood. Let me just double check what we have so far. Okay, so let me just pose the question.
Get out of the rabbit hole. You need to be.
All right, so it's very important to understand to identify the keywords. The keyword for that was less than, right? So this is the left toe.
Other exactly. Other system. Okay, then this. Oh, you can.
All right, so we're gonna test on the so make sure you're gonna put this is less, this is equal. You're gonna go with the mean. We're testing on the population mean, less than 12,720. I don't think the comma is necessary for this part of the question because I don't think that's important. The comma is just like 12,720. I believe the system still be okay with that. So since the question gives the population standard deviation that we have to use the z-test. So now the z-test actually like so back in like 18 like 96 or something that people actually develop a test basically work really well with a small sample, especially when a population the standard deviation not given, which is why the z-test is no longer like the main thing that we have, but still be very important when you look at the sample size. It's all when we have like big enough sample size, we convert to the normal curve. So, and let me just compute the. Oh, we basically do the same thing for that. All right, so this is the left toe. Okay, so the lab tail meaning that the sample mean basically less than the testing population means, which is why we always have a negative sample statistic score. So let me just show you what it is. So we're gonna take um divide first. We're gonna do the same thing. We're gonna take 12,000, I'm sorry, 12,000, I'm sorry, 11,943 minus 12,720, and then divided by the standard deviation, which is 2,200 over radical, and we have 60 cards. All right, so the first two steps always be the same, so you don't necessarily have to worry too much about this. Okay, so now we can compute it on a calculator.
No, we haven't done work. Oh yeah, that's not, we haven't covered, we haven't done.
All right, so now instead of we looking at the critical value, so we go into compute a probability that is associated with the statistical value that we have with negative 2.735 or 2.736. So so we need to find a probability that associated with, so this is on a left tail, we have to go on the left side of the probability, so we can really think of that 3.6, something like that, 3.57. I don't think that mattered that much in terms of decimal point. Just want to let you know in terms of we're looking at the critical, the score, now we're looking at the probability. The exact same concept. It doesn't really, um, you know, doesn't seem a lot of difference. All right, so the testing value that we had was the critical value, the critical value is 5%, the alpha at 5%. Okay. And what are we trying to do? We're trying to look at the p-values that go with the z-score based on this, based on the sample size information. So this is what we have for the p-value. We go to z, which is negative 2.7357, and then you want to find the p. Okay, this is the what we call the p-value. So so we can use a calculator to compute it. The, it's is the z, p of z of negative. I'm so sorry. 2.736357. I think that doesn't matter that much. It's 0.0031. Okay.
Alright, we're gonna make sure that when we write the radical, make sure that we like it's different and.
All right. So it's about like 0.3%, right? So the alpha that we had was is so much bigger. The testing value was like 5%, right? So this is no 1%. So the whole thing was like 1%. Okay. So since the alpha is 1%, or 0.001. So we can literally check that since the p-values equal to 0.0031 was less than the alpha. So that doesn't stay in the confidence level, which is good. So there's no way that so we can basically we can simply accept H1. We're gonna reject HO. and accept the claim. Okay. So when the p-value is greater than the alpha, then we do not accept the claim. When it's less than the alpha, we have to reject and accept the claim. As simple as that. Okay, so I don't understand this. So you have to write a comma, but I don't think that mattered too much. Every thousand plays, that makes no sense. But anyway, so that's what we have so far. Any question? All right, so no question. Uh, and all right, so significant level might affect the um the claim or not affecting the claim. Something that really like, so let's say we take alpha if 1%, we basically the validity of the test is simply 99%. So the bigger the confidence, the better it is. So when we take like 1%, gonna give you like it's gonna be harder to reject H1 to reject HO. It means that it's gonna be harder to accept the claim, but it's gonna make your report, your test very, very strong. For 5% is like we're taking 5% risk. That's not too bad. That's pretty good as well. The standard score is 95% confident level. The same thing with critical value is 10%. So that meaning that I would say your statistical analysis will be 90% valid. I mean, even if you make that decision, meaning that there'll be 10% chance that it might go wrong. Okay, so that's what it means by the critical value. Um, so so we can also looking at the um looking at critical values. You work with two that would not be graded. Yeah. And then it should be 10%. Or maybe none of these above. Um, so the Z of 10%, something like that, is 1.28. It's not one of these. Okay. The critical value as alpha equal to 1%. It's you're gonna go for T of 0.005. We have to divide it by two because that is two tests. So let me just copy that first. Like double check why you make it like kind of the other way around. Bring two to the third and to the sixth under the same radical sign. You will get two to the nine, right? Under the two. All right, so since the reason why I have to take like the Z of 0.005, we can work on the two tail. And then the same thing, we're gonna go look at the Z of 0.025. And that one was just look at the Z of like 0.05. And then don't forget to check plus or minus. All right, so apparently you're gonna have something like negative 2.5776 and positive 2.576. And then the same thing for that, we can also take the Z of 0.025, which essentially will give us 1.96. And then the positive 1.96. That's 5%. So we can do the Z of 10%. That's going to be 0.05. Its two tau is 1.645. Yeah, it's take me long to write them down. And then the test statistics for which of this level would be no hypothesis be rejected. Oh, I'm so sorry. Um, So the null hypothesis would be rejected if just want to make sure that we got this one done. All right, so the z-score that we found was 1.16, right? And then it's literally too small for that. It's too small compare. So the statistical value, the z equal to 1.116 is too small. So very likely that we cannot. So we cannot. Very likely that we do not reject. We cannot reject HO with any of these with any of these critical values. Okay, so apparently that we have all, so this have to be none of the above. Okay. Yeah, this one will not be graded, so I don't think that mattered that much. So just solve it. Yeah. Yeah, we only agree for that. This is a scratch board where it comes with two toe. We just want to test on it, like maybe one toe, you're gonna two toe would be negative 1.96 to positive 1.96. And then we test on the like 1.116. So there's no way that we going to accept. I'm sorry, there's no way that we're going to reject no hypothesis because the no hypothesis right here is still staying inside of no hypothesis. So there's no way we can do that. Okay.
Yeah, that is just all. I'm just reporting. Well, I mean, I'll report the bug, like, it makes no sense.
So we failed to reject because because it's statistical value. It stay inside, right? Of the bounds. Right. So any point that go inside of the HO that we have no information, we have no clue at all, we cannot say anything.
You get rid of the radical, like your whole.
And this one is H1.
So that you can get rid of that third of ten, that's the whole.
Okay.
Um,
All right. Anyway, so let me just go to another example. So I think we need to do a lot for the t-test. I believe you can do all of this yourself. And so I'm gonna go to like the critical value approach. This is matter to me. This is matter to us. It might be the question. It's basically the same thing, but the other previous topic, just like you have to use the chart, you have to use the testing, something like that. Just do it. Um, so it's for this, the sample standard deviation was given, which is 24. S equal to 24, so we have to use the t-test, right?
Yeah. Yeah, no,
All right. So for the hypothesis, so we need to highlight a keyword. The keyword is very important. If you write it down, if you write it correctly, you're gonna get point for that for sure. So the testing was greater than like 120, right? So it's keywords is greater than 120. All right. So now we just simply do is greater. So take the mean is greater than 120. On top of that, just set the equal, the mean equal to 120. And then we have to use the t-test, and the degree of freedom can be computed by um, equal to 24 minus 1, which is 24 minus 1 is 23. So don't forget to put it down 23 in this case. And then we can also compute the t-statistics based on what we have so far.
Your radical as well as your I as this variable. Like you can act like. What about that? Where like you have to put it.
Then we can compute the t-score.
Yeah, yeah, that was a good point.
We take the sample mean, subtract.
That is the one thing about I.
Subtract the testing mean in this case.
Basically, the thing that you have to, you're working with I. And in general, when you're working with I, like, have to remember that this
And divided by standard deviation.
like as a unit comes first, in the sense that I squared
Over radical n.
normally do with the product of you cannot use the product rule on this.
Basically, you can't multiply
You
negative
can't,
1
yeah,
times.
so you can't use this.
Right. So we can just simply divide. So the sample mean was 125
So this
minus the testing mean was 120 over the standard deviation was 24 and divided by the square root of. Oh, okay. So n was 9, is not 24. I'm so sorry. 9.
because it's kind of like see it as
I'm
like
so sorry about that.
I as square root.
Okay, so n equal to 9.
We're squaring I. You were doing this. Then
So that'd be 9 minus 1 is 8. I'm so sorry. So that'd be 8 degree freedom.
Kind of like define what the reason why we built I in the first place. So
All right, so we're gonna do that, and then we're gonna take divided radical 8. So this is what we have.
What's the absolute number like symbol around it?
Oh, yeah.
And then that's gonna give us the answer equal to 0.5.
That is something to remember when you will be dealing with more. It's something to remember that. So when through the
Okay, no problem, Nico. 0.589, something like that. And we're going to take the critical values as well.
Yes. Well, I mean, it's for
0.5893, whatever.
So the reason why
So the critical value of t based on the alpha, so the alpha was like 5%. The significant level is alpha 5%.
this, but this is also obviously whether you have plus or minus the square root
I'm so sorry.
at the same.
Actually, 9 is not 8. I'm so sorry about that. The n was 9, so it have to be 9. It's not 8. When you compute the degree of freedom is 8, but when you do it on a calculator, it's have to be 9. Okay, so I'm so sorry about that. It's 0.625.
Like in general, when you work with a variable, you're trying to solve for it. then it gets twisted. You need to, you have to remind yourself that like actually like it could be this. So
And then we need to find a critical value based on what we have. So we're gonna look at the T of this is one tau is 0.05 and degree of freedom equal to 8 degree of freedom. So when you do the math, you have to divide by radical 9, but when you look at the t-score, you're gonna take 8 degree of freedom. Okay. And that's essentially gonna give me the answer will be 1.85. 1.859. $1.8595, something like that. So, all right. So, what can we say? Because this one the t statistic was too small, so you cannot say anything. Just say no. Oh yeah, I forgot to change that to 8 degree freedom. Okay, it should be good. Okay, so this is what we call the critical values. And we're gonna say since uh the sample statistics, I mean statistical values that we had was like 6.25, and 0.625 was less than the critical values. It's 0.05 at 8 degree of freedom. So meaning that we do not reject HL. We can accept the claim. Accept the claim, right?
Run back into like the room full of smoke.
Right. So rejecting the HL going to help us accept the claim, but if we do not reject or you fail to reject, so we cannot accept the claim without problem. So it's as simple as what we have so far. Any question? Yeah, we're going to use T when the sample standardization is given. So meaning that we have to compute the degree of freedom. Yeah, for objective, that's 7. For objective 7, that is correct. For objective 8, there are a lot of factors that need to be taken into account. But generally, when you only have a sample standard deviation, do not have a population standard deviations. When it comes to the exam, you have to know which test that we're going to use. So when the question gives us a sample standard deviation, then we have to use the t-test. When a question gives us the population standard deviations, then we have to use this, then we have to do the z-test. So that's kind of like different from what we have so far. Yeah, this is the population standard deviation. Okay. Something like that. I just pointed out. That is a good question. The same thing for that. Give us the population standard deviation will always be given. Then we have to use the z-test. This is very unrealistic because if you know the population standard deviation, what the point of doing like testing on the means? Because we actually know exactly how many people that lives in the population. So which is why the t-test is more popular at that times, where it's basically focused on a very small data set points. It's also when you don't have the population standard deviation. All right. So this is why we need statistics because we did not get the size of the population. All right. So anyway, so let me just focus on the other part. The p-value is basically the same thing. Let's do the p-value approach, and then we're gonna come back to it. I think yeah, you can work through this part. Remember that the hypothesis must be tested on the population mean for objective 7. Um, all right, so let's do this question. I'll let you go. And of course, the first thing we have to highlight would be the sample standard deviation that basically tells us to u the t, right? Equal to 20. And then we're gonna do the t-test. Okay. All right. Then the keyword is I think the same question, is it? No? Can I but we do the p-value, but it doesn't matter. Is it the same question? Yeah, it seems like a same question, but anyway, so it doesn't matter. So it's greater than 120. So that's the keywords. So it's just basically an right tail test. Okay. So now we can simply do greater than. So the mean was greater than 120. On top of that, just set equal to 120. And then this is gonna be a t-test. The oh yeah, got it. And then we can compute the statistical value based on the sample information. We're gonna take the x bar equal to 124 minus 120 over the sample standard deviation is 20 divided by radical 14. So don't forget to compute the degree of freedom. We have n equal to 14. So degree of freedom is n minus 1. So that equals to 13. Okay. So, but when we do the math, it still have to be like 14 instead of 13. No problem. So when you do it on a calculator, you have to look at 13 degree of freedom, but when you compute a map, you have to be 14 in this case. So let me just double check. So we're gonna have that equal to 0.41748. All right, so that's the critical value. So now we need to look for the probability that is associated with 0.748 from the statistical value. So the p-value can be computed by, so that one was positive. So it's on a right tail. So the p-value is going to be associated with the t equal to, this is a critical value, 0.748. Okay, whatever it is, 0.83, just making sure we take 4 decimal points. And then we need to find the probability. So since this is on the right tail, so we have to use a sign greater than, this the t greater than, so this is going to be the p-value. So the p-value of that was equal to the p of,
Is it not?
the p of t is greater than that, and with degree of freedom equal to 13. I don't think we need a lot of decimal point, just making sure we don't take so many of them. I can copy the entire thing. All right, so we can literally check on the calculator that it's give us 0.23379.
Two? Okay.
So, no, bring it in. No, no. Switch, it's like, right, equal. Equal. So, we're in.
So essentially that gonna give us the p-value equal to 0.23379. Um so let me just fill up the blank first. The critical value that we found was like 0.7748, something like that. 0.83. Okay. And then the p-value that we found was the probability equal to 0.2338, something like that. All right, so now this is about like 20%. So a p-value basically stay inside of, so this is take up to like 20%. The testing value that we have with like 5%, the testing p-value, the testing probability, this we only take up to like 5%. I'm sorry, 10% actually. I'm so sorry. So the alpha that we take like 10%, which is pretty high. So the alpha is 10%. It's 0.1. So since the p-value was greater than, it stay inside of the comfort level, stay inside of the no hypothesis, so we cannot say anything, right? It's greater than the alpha.
If I wanted you to rewrite, if I wanted you to, if the question requires you.
So we do not reject
Rewrite it in.
HL.
Um, Yeah, nice word.
So we cannot claim anything. We cannot say anything because we don't have enough evidence just to say that. All right, so that's what it is. I know we're going a little slow. I just want to make sure that we get through the concept. It's a very important thing. Uh, the uh, the confidence level, like it's basically represents the HO basically means that we do not have any information. So any point that go inside of confidence level, we say nothing. Um, where we take, so 5% would be the region that we tested, and then we have 20%, which is so much bigger than what we do expect. So we cannot say anything for the test. So we just say no. Okay. All right. I believe that's pretty much it. Any question? Any concern? We forgot to take degree of freedom equal to 13, and then just check it. That should be good. Any question? Yeah, every hypothesis test is gonna do exactly the same thing. We have to compare the critical value with the statistical values, or we can compare the p-value and the alpha. Okay, so just go that way. Anyway, let me take attendance. I'll let you go quickly. The one the one bad thing about the Brightspace is that it does not have the function to take attendance as because the queue just get rid of that. Um, so we have to do the attendance on SL. I just want to remind you that the attendance is basically 2% added to your final grades. I know it's somewhat it's only 2%, but if you do with the handshake, you're gonna get 3%. The final project gonna be another 2% added to your grades. All right, Jasminer is here. Okay. Malika, got you. Annie, yeah, we can just say here, can leave. Until I will like go through the chat bot and then just say here if you want to go. Rachel is here. Chloe is here. I got you. Rachel is here. Selena, Sean is here. Samina is here. Sarah is here. Alexis, not here. Yi, Gao, Marlene, Malene's here. Malene's? No. Jocelyn. Jocelyn's here. Valeri's here. Nadir is here. Nico is here. Tina is here. Ariana is here. Nico again. Nico McGanner. I'm sorry, Marique. I'm so sorry about that. Sometimes just read it wrong. Got you. Karen. Karen's here. No. Meet her. Amammer. Got you. Lisa. Got you. Jer. Jer is here. No. Catherine.
Well,
Chloe just said yes. Elkin.
wait,
No. Yelly. I'm so sorry. Somehow I have a trouble spelling. Um, Damaris. Oh, Elkin's here. Okay. Damaris. No. William. Got you. Lenny. All right. Have a wonderful day. I'll see you on Friday. Take care.